Hi, my name is Emily Fung. I'm an effects artist. I've previously worked as a technical artist at Side Effects, shortly after finishing my internship there, prior to which I worked in films and television in London. Today I'm going to be sharing my workflow for scattering rocks for our short film, hopefully showcasing some of the new Houdini 18.5 tools and providing some general tips and tricks along the way. We will talk about methods to generate rocks, scattering, and finally rendering with Karma. Let's jump right in. So to begin with, we have got these really nice terrain geometry that were created by Nicola. They are highly detailed and already textured. However, we need some additional rocks on the surface. So instead of sending it back and having it remodeled and retextured, we decided that scattering was going to be the way to do it, as it allows us to iterate and modify really quickly and easily. And since we've got multiple terrains across different shots, we can do a nice procedural setup that we can reuse, which is nice. So the first thing we need to do is to create some rock geometry. So firstly, we've already got some in our archive for previous projects, some of which were provided by our past technical artist Raj for some of his projects in Houdini 18. But in addition to that, I also generated my own rocks to have more variations and to explore different methods. So the two methods that I have explored were photogrammetry and the native Houdini procedural modeling. So photogrammetry is a technique where you can take a bunch of photos and recreate a 2D or 3D model of it. And you can do that in Houdini. Using the Side Effects Labs tools, the Alice Vision plugin, you can very easily generate 3D scans. If you haven't installed the Side Effects Labs tools, I highly recommend you to do it. It's got a variety of tools that will help you to speed up your workflow and allow you to talk to other software really easily. And also some of the tools are you can just unlock and just look inside and see how they were built and learn from them. So after I've installed the Labs tools and the plugin, I went on to take some photos of a rock. I took around 33 photos using my camera, but obviously you can use your phone or any other capturing devices. So I tried my best to capture 360 degrees of the rock. These photographs are not the best, but they did a fine job actually. So after you've got your photos ready, you can jump into Houdini. So in Houdini, we can drop down a LOPs AV photogrammetry node, and all you need to do is to add images, pick your images, and then press cook, and it will generate your geometry for you. And this is a more high-level node, and if you want to go in and adjust the settings for what you need, and you can just unlock it and do that. But this worked pretty well for me. And after you've got your geometry, you have to do some cleaning up. And the first thing I did was blast out any areas that I didn't need. And then I did a pretty standard Houdini cleanup. So I remeshed it, and then I filled it, smoothed it out, converted it to VDB and back to polygons. And this was my sort of mid-res geo. But I needed a more low-res geo for the scattering, so I also generated the low-res geo. So with the low-res geo, I also used this for my texture fixing. So I had to delight it, which I used the Edgysoft delighter, and then for fixing textures, I used Substance. So overall, photogrammetry was really fun, and it obviously could help you produce more realistic results, especially when you're having a complex model. But it wasn't that necessary for what I'm doing because I'm only need some small and varied rocks to be scattered onto a terrain that's quite far from the camera. So I did go on to do some procedural modeling in Houdini as well, which I'm going to show you what I did. Again, this was not the most complex procedural modeling that I did, but it was enough for what we needed. So I've got a box here, and scattered some points. And then I just did a very simple Fahrenheit fracture. And then I picked one of the pieces. And then I clipped it at the bottom so it's kind of always on the ground. And then I gave it some randomized normals. And then I put it in a for loop. So for each point, I'm going to be clipping according to where the normal direction is. Like so. And then I just run it again so you'll get like a chipping effect for the rock. Turn this off. So you get something like this, which is an interesting enough shape for a small rock to be scattered. And I just sort of polybaffled it to give it some nice edges and then remeshed it and give it some noise. And then I also auto UV it just to give it some UVs because I want to also add some textures to it as well, some procedural texture that I'm going to create also in Houdini. Cool, so we can do that in COP, so which is what I did. So you go into COPNet and so firstly you can drop in a FOP-COP generator, which it works kind of just like a attribute FOP, so you can just build a bunch of noise on top of each other and then generate stuff like a 2D image that you can use as a texture or on maps or anything like that. So I will go through what I did here. It's not it's quite simple what I did. I just layered some noise. So to begin with, I'm using a anti-alias noise. So a little tricks that you can use to make your maps more interesting is that after you've got your noise, but before you've got your noise, you can warp it. So what you can do is you can input a noise into the position before you feed it into the noise, and that will allow you to have this nice sort of warping effect. And this is what I did with all the noises, and then I just layer them up like so. So this was the base noise that I used, like a base texture that I used. And on top of that, I wanted some cracks and some sort of like dirt, like dots. So for the dots that I created, I used the cell noise. So we can, so in cell noise, we can get this nice sort of like dotty pattern. And then we can just use a fit range to get some nice dotted, no more circular dots in there. And obviously we don't want it all over the texture, so I just layered 2 turbulence noise on top as a mask to get rid of majority of it, so I can have like a little bit of dots on my rock texture. So I just layer them together, and to get this, so you can see this is my base noise and with some sort of dirt on top of it. And after that, I also wanted to add some cracks. So I'm also using a cell noise again, and the same technique with the warping. So instead of having these straight cell noise, we'll have these more interesting kind of wobbly lines. And again, this is like too much for cracks, so I just use another turbulence noise as a mask to mask out these. So I would just have some sort of cracky looking pattern that I can lay on top of all my other layers. So that's it. That's a base texture that I did, and this is obviously procedural, and you can promote any parameters, so you can just change it outside, or you can link them according to what size you need and stuff like that. And so it's very, very handy. So this was what I used for my diffuse color, and I used pretty much the same stuff, just with a little bit of like difference in for my roughness, reflection, and bump. So this will be provided in like the example files that you can check out as well. Anyway, so afterwards you can go into create a principal shader, And to read in the texture from CopNet, you can use OP and then dot and the path of your texture, or you can just write it out in cops and then bring them back in as like a image, like a PNG or something. Cool, so go back to our rock and we just need to assign it. And there you go, we've got like a procedurally generated rock with texture as well. And that was, in my opinion, like a lot quicker than photogrammetry. Just a couple of nodes, and obviously you can build on top of it to make it more complex according to what you need. What's great about this is that now that this is all set up, all I need to do is just change the seed and I can generate a bunch of rocks. Some of them may not be perfect, obviously, but the majority of them, they're usable and you can work with them. I can change the seed of the scattering, I can change which one I'm blasting out. I can even just randomize the normals a bit. And I can generate a lot of rocks in a very short amount of time after I've built this. So that's kind of the advantage of procedural modeling. So this were the two. So this was the photogrammetry and the procedural rocks that I have created, and I think both of them, are valid to use in this task. But for this particular project, I definitely prefer the procedural workflow. But it's definitely something that you need to choose according to what you're doing. But I think both methods are interesting and fun as well. So we've got our rocks, and we will now move on to scattering. Cool, so let's jump back into Houdini. So we've got our geometry, and sometimes when you receive a geometry, it might not be ideal for the scattering purpose, so some cleaning up might need to be done. So here I split out my geometry because we have got the top rocks and the base layer, and they're quite dense because they're highly detailed. So I did poly reduce it a little bit. As long as the main details, you can still see the main details, then you can make it as low res as possible. So it would just make the whole process a bit faster. But obviously, like, you need the cracks and everything to still be there. So after you've cleaned up your geo, you can start adding mask attributes to it for scattering. In Houdini 18.5, there are a few new nodes that you can use for masking, and that are very handy. So the first one I wanted to talk about is the Masks by Feature node. So the Masks by Feature node is a new node that is super useful, and it allows you to generate really quick results for my masking. So firstly you can do it according to direction, which is what I did here. So this is a general mask I created so that because I want to mask all the areas that are more vertical, because I don't want any rocks scattered on those areas, because they'll just roll off the cliff, right? I masked those areas according to the angle and the direction, and then you can just save it out as an attribute, like so. And this is a general mask that I use to clean my other masks. So the next mask I used was the distance from geometry node, and it's pretty self-explanatory. You just have to plug into geometry and generate the mask from it. So there are different options that you can use, as well as you can ramp it and then create your attribute from there. So this was what I used to get the so I can scatter more points near where the surface rocks are. And after that, I also added the mask for the cracks, and I'm using the mask by feature, the ambient occlusion option here. And then all I did was that I merged them together, and I did some additional mask, added some extra noise to it, so it's not all over all the cracks, so it's a bit more varied. So this is one of my layers. And then the next layer that I did, it's the overall scattering mask. And I just used two noises and layer them together because I didn't need any specific sort of cracks or anything like that, so I can just use the generic sort of attribute FOP to do that. And this one was a bit more manual because I also added an attribute pane SOP, so I can address any notes, any specific places that I definitely don't want rocks, or any art directable requests that I can just use for this in this mask. And lastly, I've also got this little mask for any big rocks that I want to scatter, so very sparse. And this is for the base level, and for the top rocks, I just did a mask by feature, and again, ambient occlusion to get all the cracks, to give a mask attribute for the cracks. And then, so this is actually now ready to scatter points on. And in Houdini 18.5, we've got the new Scatter and Align SOP, which I really like. It's it's really handy. So I'm going to show a few examples of what we can do with it. So firstly, here we just use a grid, and then we would drop down a Scatter Align SOP. There's a lot of attributes that is quite similar to what we had in the scatter SOP. So we've got density, and we've got like relax iteration, stuff like that. I'm just going to turn this off for now. And then, so I'm just going to copy some boxes to show. So it's easier to show with the copy geometry. So what you can do in the Scatter Align SOP is you can obviously change your coverage, so it's how much you're covering, and the density scale, so like how dense you want it to be. And there's also the options for randomization, so you can randomize your rotation and your direction and all that kind of thing. And then you can also use relax iteration to relax your points. And although this tries the best to solve overlapping, it could still happen if your geometry is too big and stuff like that. So here's the option of remove overlapping points. So it will help you to remove, just points that are overlapping. And you can change the overlap tolerance to see how much you want to keep. Cool. So so that's the basic of it. And the Scatter Align SOP together with the new attribute from pieces SOP, it just helps the scattering process a lot. So the attribute from pieces, just like the name, it's getting attribute from the pieces, and then it will put it on your points. So here, we will be getting the name attribute where we already assigned, for example, the sphere. We'll just give it a name attribute called sphere. And the box is called box. So in the attribute from pieces, we're going to assign these names randomly onto the points, as you can see here. Well, cycle means it's one and then the other. And then you can also do patches or noise or just random. So what that does is it will give it the name, and then all you need to do is you can go to your copy to points and turn on the name attribute. So as you can see now, you have the pieces randomly scattered according to what you did here. So if I do patches, you can change those, offset, shuffle, the seeds and all that. It's super handy for random scattering. But apart from random scattering, there are also other things that you can do with this. So here's an example of copy based on p-scale. So I've got a grid again, and I'm actually just giving it a density map, just like a noise. And here I'm actually using the attribute adjust flow, which is also new in Houdini 18.5. It's similar to the attribute randomize node, but it's just got a few more options, and I really like this. And yeah, you can do just give an attribute and you can adjust it. You can do all sorts of operations on it, and you can do noise and range and post-processing to set up your fit range and stuff like that. And for me, it's kind of like an updated version for the attribute randomize, so I quite like this. Anyway, so I did this for the density, and I'm feeding the density into the density attribute, so I'm getting these points scattered like this, so pretty standard. And then what I did was that because it will provide you a p-scale attribute after the scatter align in here, and that would be generated according to like your coverage and your density. It's kind of automatically updating it. So obviously you can get rid of that and make your own p-scale attribute. But if you're using that, for example, in your attribute from pieces, you can use the mode map attribute, and then you can choose the attribute which I'm using p-scale, and then I'll give it a explicit range, which means, for example, if the p-scale on the point is from 0 to 0.2, I want the pieces box to be copied to the name. So here we can see if the p-scale is smaller than 0.2, then the name will be box. We'll just scroll down to find a bigger piece. So let's say 0.5, that would be a sphere. So visually it will look like this. So you can see that the small pieces will be the box and big pieces will be torus. And to show you better, you can see if I just change the p-scale after the scattering, you can see that it updates automatically like so. I think this is really handy. You can do all sorts with it. This is one thing that you can do with this. And then the next thing I tried is scattering LODs. So I've got a camera and I've got a grid again. So I'm just scattering again some points on it. And then what I did, I took the camera and gave it like a UV attribute using the camera. And then I used that to create a ramp. So I'll find out the distance between each point to the camera and then give it an attribute accordingly. So if it's close to the camera, I'll have it a different I'll give it a different number for how far it is from the camera. And then in the attribute from pieces node, I'd say if the LOD is 0, it'll be a box. If it's 1, it'll be a sphere, and if it's 2, it's a torus. So this is kind of representing if it's close, then it'll be a high detail geometry, and so on and so on. So when we copy it, you can see, can control by our ramp here. And in the camera, if we move it, and we could also update it as well. So that's another handy thing you can do with this 2 nodes. So lastly, in the Scatter and Align SOP, it allows you to layer them up. So here I've got some big points, which I want them to be the main points. And here we can give a tag name. So I'm just going to say sphere. So these will all be spheres. And I'll give it a p-scale attribute. And then I'm going to feed this into the second input of another Scatter Align SOP. And then in this mode, we can change it to scatter points around constraint points, and the constraint points will be your second input. And what this does essentially is that it will scatter around the points that you fed in. So here you can add a void constraint points. And as you can see, it'll be scattering according to what radius you give it. And for this one, we're going to give the tag name box. And with that, we can assign them in the attribute from pieces SOP. So if the tag name is box, we will give the piece box to it. So now as we copy it to the points, we can see that these boxes are scattered around the spheres. So this is quite an interesting technique if you want to do things like pebbles and have some grass scatter around it. You can use this method. So, none of these you couldn't do before, but it's just a lot easier and quicker now with the new SOPs. So I recommend, having a look at it and play around with it. So with these techniques, we can scatter our rocks. So these were the final points that I had. It's quite a lot of points. And then I just sort of copy some geometries onto the points. And I also did some cleanup afterwards, so just calling it according to the camera. So yeah, that's how you can scatter rocks with the new nodes. So finally, I'm going to just be sharing a little bit about rendering in Karma. Cool. So I'm just going to show a different shot just because this shot is quite nice. So we've got a base and additional rocks and the astronaut. So we didn't do the project using the USD pipeline, or we didn't render in Karma, but as a test, I would show you what I did when I was testing. So you can obviously import everything using the scene import and then just render it, but that could be slow if you don't write them out as USD file first. So what I did here, I did just really quickly. I would import every element separately and then write out USD file for each thing. So for example, for the base, I would import my base and then assign a material for it. And then I used configure layer to give it a path to save the USD file to, and then I'll write out the whole asset. And I just did that to everything. So I did it for the astronaut, for the base, for the rocks, as well as the camera and the lights. So as you can see here, we will have these nicely grouped and stuff. So obviously, if you're working with multiple people, you wouldn't really do that in one file. You would do them in separate files. So layout would be one file, and modeling would be one file, and such. But because I was just doing it by myself and testing it on my own, so that's no problem. To bring all the USD files in, you can use the stage manager. So all you need to do is drop down the stage manager, and you can go to the right path and then just drag and drop into the scene graph path here. Then you'll get all your USDs. So you've got your camera, you've got your lights and your props. And then to test render, I drop down at Karma render properties, which I just change the resolution and turn off depth of field. And then I just did a test render by swapping it to Karma. So it will take a second to load. And then it should hopefully render. Yay. So we've got a test render using all the assets. So now if you want to play with the lighting, we can, for example, drop in a light mixer. And you can drag and drop your light. So for example, I want to test out with sunlight. So I'm just going to render this. And then I can save it out into the render gallery. And then I can change the settings. For example, I want a red light. I can just change it up and it will update it. And then I can save it out again. And then maybe I'll do like a different color as well, to yellow light. Cool, so I've got 3 test renders. And you can check them out by just double clicking here and they will show in the view port here. So let's say I want to revert back to another version. All I need to do is right click and then revert network to snapshot. And here you can see that it will return your network to whenever this snapshot was created. So that's very handy if you're doing, lighting iterations or anything like that. Yeah, and then you can just drop down a Karma node and render your sequence. So so there you have it. So an overview of how I scatter the rocks for this animation, and thank you for watching.